Dear student, in this video, I'd like to explain how to perform chi-square test for independence. The example I will cover here is the same example was covered in the theory class. So the file name is operation. First of all, you need to download the file from MS Teams. It's already downloaded in my RStudio environment. I can click on that file. If you see, the file looks like a two-way table. This is called contingency table. And we have two categorical variables. The first categorical variable is the procedure preferences, and this categorical variable is a column categorical variable with three different categories. The second categorical variable is in the row, and that categorical variable is a profession, and we have two category in profession, which is nurse and doctor. So we want to see whether there is any association between the preference of procedure and the profession. So to see the association, we use chi-square test. In RStudio, to perform chi-square test, we are going to use a command called chi-sq.test. And then we write the table name, which is operation. In this case, you don't need to use the sign dollar because this is not like a data frame. It's like a two-way contingency table. So click on run. You are going to get your information or the output in the console window. The first output we get is x squared, and that is the test value, the degree of freedom for the chi-square, the p-value. If we compare the p-value, here we have very small number because the power is negative to 6. So if you compare the p-value with any alpha, for example, alpha 0.05, your p-value is very small compared to alpha. So that's why we conclude that we have to reject the null hypothesis. In chi-square, the null hypothesis, or H0, we say that there is no association between the variable. So we need to reject that hypothesis, and we have evidence that there is association between operation and preference of procedure and profession. If we want to get more informations, like as you get in the theory class, we have to save the chi-square test result under any name. For example, we will save it under the name result, and we will put the code of the chi-square under the result. So we will get the output of the chi-square inside the environment as a name result, list of 9 outputs there. If I want to extract this list, I can just write result dollar. I'll get the first option statistic. What is statistic? Statistic gives you what? The test value. Already we have it. Okay, so if I press on result dollar, parameter. What is parameter? Parameter gives you the degree of freedom. Result dollar p-value. That is the p-value we already got. So what else we need? Why we have saved this in the environment as a list? Because if you want to obtain the expected frequency, then you have to click on this one. So click on the expected. It gives you a table. This table is different from the table we have already. See, these tables values are called the observed frequencies, and these tables values are called the expected frequency. Okay, that's what we do in theory class. We need to find the test value by knowing the expected and observed frequency. How about the critical value for chi-square? In the theory class, we are going to use a table, but in practical, we have to obtain the critical value using the command, start with Q, and the distribution is chi-sq. First of all, you should know that chi-square test is like if distribution test, and it's always right tail test. So 1 minus alpha you need to use. And if you don't enter the degree of freedom, you will not get the answer. So you have to enter the degree of freedom. Degree of freedom already we know it's equal to 2. In the theory class, we found that the degree of freedom is the multiplication between the r minus 1 and column minus 1, number of column minus 1. So we can run, and that's the degree of freedom also we got in the theory class. So this is the first example. Let's see the second example. Download the file name residence. We have already downloaded. This is the file. And this is like a table, two-way table. We have one variable with 3 categories, another variable with again 3 categories. We want to see if there is any association between this categorical variable with the row categorical variable. So the same step we are going to follow. First of all, chi-square test. Write the file name. Don't use dollar, just write the file because this is a table. We are going to get the test value. So that is the chi-squared value. The test statistic is already there. The answers are already, I have computed and displayed here. The degree of freedom this time is equal to 4. The p-value is equal to 0.5569. So compare the p-value with alpha. If we say we are using alpha 0.05, the p-value is more than alpha. So that means we have failed to reject the null hypothesis. In that case, we say that there is no association between the variables. That's what we found also in the theory class. Now, how about how to find the expected number? This chi-square test code doesn't give you the expected frequencies for each cell. So how do we get it? We need to save with any name. You can say result 1, for example, or result 2. So this is example 2. And put your codes inside that. Then extract the expected frequency. So extract the expected frequency. Result 2, we press on dollar and then click on expected. You get the expected frequency for each cell. So this is the expected frequency for um, each cell. Okay. What's about the question? The expected number of advanced degree in urban. It should be advanced degree, the third column with the first row. The expected frequency is 9.545455. How about the critical value? The command we use is qchisk, and then, as I mentioned before, chi-square test is a right tail test. So 1 minus 0.10 alpha. The degree of freedom this time is equal to 4. So the critical value is equal to 7.77944. That's regarding the chi-square test. Thank you.